Now, class, let's talk about our next lesson, which is all about percentage ratio, strength, and other expressions of concentrations. So how do we express the concentrations of our solutions? Okay? So basically, class, we can express kasi the concentration of our solutions in so many ways. Na-discuss nyo dati, molarity, normality, that's one way of expressing concentration. Okay, another way of expressing concentration, class, would be through percentage. Like halimbawa, pag sinabi kong my solution is 10% of the, of whatever solute I'm using. Okay, pwede rin naman as ratio strength. Okay, and other expressions of concentrations like parts per million, parts per billion, okay, mga ganun klaseng expressions of concentrations. So our objectives for today's class will be simply to define the expressions percent weight in volume, percent volume in volume, percent weight in weight. Okay, usually it's expressed like this. Okay, so halimbawa, nakakita ka ng 10% W per W. It means that's an expression of weight per weight. Okay, meaning ang weight, ang solute mo is expressed in grams. Okay, and then the total solution is also expressed in grams. Total weight of the solution is expressed in grams. Or what about, say, for example, sabihan ka, my solution is 50% WV. Ibig sabihin nun, class, my solution contains 50 grams of the solute and the total solution is 100 ml. Kaya nga siya in volume. Okay? So, pwede rin naman kasi percent volume per volume, and so on and so forth. So, those are some ways wherein we can express concentrations. And the next is to define the expressions as ratio strength. Okay? Be able to convert percent strength to ratio strength and vice versa. Madali lang naman to. Okay? Then calculate the percentage strength and ratio strength of pharmaceutical preparations. Apply percent strength and ratio strength to calculate the quantity of an ingredient present in a pharmaceutical preparation, and to apply strength and ratio strength to calculate the quantity of an ingredient to use in compounding a pharmaceutical preparation. Now, let's first talk about percentage, class. I think madali lang naman to, right? Most of you know this already. Percentage, class, simply percent by the 100 or in 100. Okay, so usually, class, it's expressed as percentage. So normally, class, if you have a numerator divided by denominator times 100 lang yun for you to get percent. Now, if I want to convert, class, say, for example, 91%, gusto ko siya i-convert into decimals. Anong gagawin ko? Yes. Yes, Miss Eva?
Divided by 100.
Okay, class. It's as simple as dividing 91 by 100. So by dividing it by 100, so 91 divided by 100, mako-convert natin siya into decimal, which is 0.91. Alright? So, yeah, basic na to. Feeling ko alam nyo naman na to. Now, what are some of the ways wherein we can represent percentage strength, okay, based on anong units ang ginamit to compound them? Okay, we have, class, the following: weight per volume, volume per volume, weight per weight. Okay? Now, how do we do this? Pag sinabi ko, class, weight per volume, halimbawa, sinabi ko, my preparation is 10% WV. 10% weight per volume. Ibig sabihin, class, it's a solid in liquid. Meaning, solid yung solute ko, tapos ang diluent ko is what? It's a liquid. Okay? Kaya siya weight per volume. So, ibig sabihin, class, ang solution na mabubuo ko dito, or ang mixture na mabubuo ko, is in fluid, is in liquid form. Kasi weight per volume. Ibig sabihin nito, class, ito yung aking, tandaan nyo to, pag expression classes pa ganito, yung weight dito would refer to your solute. The V here would refer to solution. Okay? What type of solution are you creating? Or ano yung measurement ng solution mo? Is it in terms of weight? Are you measuring it in terms of volume? And so on and so forth. Now, kapag, class, percent weight per volume, ibig sabihin nito, okay, so solid and liquid, that is usually expressed in grams of constituent in 100 ml of a solution. So, if I say, class, my concentration is 10% weight per volume, ibig sabihin nito, class, my solution is 10 grams solute, tapos 100 ml ang total solution. Nagets ba? Nagets ba, class? Ulitin ko Pag ang expression ko ng aking solution, say for example, ito kunwari, itong alcohol na to. Okay, sabihin ko, this is 75% weight per volume. 75% weight per volume. So, ibig sabihin, class, so 75% weight per volume. It means it contains 75 grams of the solute, which is alcohol. In grams ko siya mineasure. Tapos, in 100 ml solution. So, ibig sabihin, class, 100 ml of this contains 75 grams of alcohol. Nagets ba? 100 ml of this contains 75 grams of alcohol. Right? So, yun yung expression na to. Yes, Stephanie. May question?
Hindi po. I mean, naintindihan po.
Naintindihan ko. Okay. Sorry. Alright? So, ganun siya, class. So, ibig sabihin, pag halimbawa, nagsabi naman ako, 5% weight per volume. So, ibig sabihin, class, if I express this as ratio, it means that there is 5 grams in 100 ml of the entire solution. Okay? Kaya siya weight per volume. So, ibig sabihin, pag ginawa ko tong weight per weight, ano ibig sabihin nun? 5% weight per weight. Ano naman ibig sabihin nun? It contains? Anyone? Okay, this contains 5 grams of solute in, dahil weight per weight, 100 grams ang total solution ko. Alright? Now, tandaan nyo, class, pag nag-per percentage preparation tayo, expressions of concentrations as percentage, ang unit natin lagi dyan is grams and ml. Not unless stated. Okay? Automatic yun, class. Pag nakakita ka ng, say for example, sabihin nila, 7.5% weight per weight. So yung weight dyan, obviously, this will always be expressed in grams. Volume will always be expressed in ml. So meaning, 7.5 grams of solute in 100 grams of the entire solution. Are we clear? Are we good? Okay. So pag sinabi ko halimbawa, okay na yun. Basta nagets na yun, right? So solid in liquid, pag weight per volume. Plus, importanteng alam nyo ito kasi mamaya mag-ratio and proportion tayo. Okay, using these kinds of percentage. Okay? Now, what about percent volume in volume? So usually liquids in liquids. ML of your solute in 100 ml of solution. Right? So kung halimbawa, 5% volume per volume. So ibig sabihin, class, that's 5 ml in 100 ml of the solution. Okay? Ganun yung expression as percent, as ratio. Okay? And same thing, class, kung weight per weight naman. Grams in 100 grams of solution. Okay? Alright, so normally, class, ang gamit natin ng percentage na weight per volume would be in solutions or suspensions. Minsan ginagamit ito for ophthalmic preparations, nasal, otic, topical, or parenteral preparations. Okay? Ang volume per volume, class, kadalasan ginagamit ito for aromatic waters. Okay? Aromatic waters, class, ito yung ginagamit as flavorant, pampabango ng mga preparations natin. Kaya halimbawa, lalagyan mo ng essential oil, citrus oil, okay, para pag ininom nila, medyo citrusy yung lasa ng aromatic water mo. Or for gargles, ganyan-ganyan. Ginagamit din siya for topical solutions and emulsions. And the last class, yung weight per weight, kadalasan ginagamit to for ointments, creams, and gels. Kaya halimbawa, pag sinabi kong 10% benzoic acid. Benzoic acid. Tapos 10% weight per weight benzoic acid. So, ibig sabihin, there is 10 grams of benzoic there for every 100 grams of the solution. Okay? 100 grams of the solution, class, of the solution. Are we clear? Ibig sabihin, yung 100 grams na to, andyan na si 10 grams na benzoic acid. Okay? Kasama na rin si dilute. Now, kailan natin magagamit yung discuss natin kanina, which is specific gravity. So, class, maisisingit natin si specific gravity dito, okay, as a means, class, of converting our values. Like, say, for example, gusto ko in ml given siya, pero kailangan ko siya in weight, in grams. So, therefore, ano gagamitin ko para ma-convert yun? Kailangan ko si specific gravity. Correct? So, halimbawa, 100 ml. 100 ml yung solute ko. Kunwari, 100 ml solute, tapos, this to make, dissolve to make 100 ml solution. Okay? Kunwari, ito yung scenario natin, ha? 100 ml yung solute, tapos, I want to make 1,000 ml solution pala, sorry. 1,000 ml solution. Okay? Ang sabi tapos dito, class, express in percentage weight per volume. So, kunwari, ang specific gravity niya is, say, for example, 1.02. Kunwari lang naman, 1.02. Okay? So, ang solute ko is 100 ml. Ang total solution ko is 1,000 ml. So, express daw in percentage weight per volume. So, obviously, class, anong gagawin ko dito? Para ma-express ko siya as weight per volume, I need to convert my 100 ml solute into grams, into mass. So, gagamitin ko yung specific gravity natin dito, which is 1.02. And to get the mass, ano lang gagawin natin? Okay? So, sabi nga natin, yung formula natin is just simply volume times specific gravity. So, weight is equivalent to volume times specific gravity. Kasi alam naman natin na ano na yan. Baga density na rin naman yan eh. So 1.02 times 100, you get 100 grams. In grams na yan, ha? 100 grams. So I'm going to express this now in percent weight per volume. So that would just simply be 102 grams divided by 1,000 ml. Okay? By 1,000 ml times 100. And therefore, 102 divided by 1,000 times 100. That would be 10.2% weight per volume. Nagets ba, class? Very good. Isa pa. Okay, that's 10.2% weight per volume. Now, assuming, class, ito, assuming naman, hindi ko na gagamitan ng specific gravity. Okay. 100 ml of solute. So, ibig sabihin, kung ito yung baso ko, okay, ano ang total volume nito? Kung ito yung problem ko. Ang total volume nito would be 1,000 ml. 1,000 ml. Total volume. Okay, would be 1,000 ml. Tapos within this 1,000 ml, meron kang 100 ml ng solute, correct? Correct? Okay, basta 100 ml solute, nilagay ko dyan. Tapos ang total volume nito is 1,000 ml. Okay, the total volume is 1,000 ml. So obviously, class, I can express, may concentration ito. Okay? May concentration ito. 100 ml nung solute ko, nilagay ko sa solution na total is 1,000 ml. Now, class, I can express this in various concentrations. Ang pinakamadali ito would be to express this in percent volume per volume. Bakit? Ano lang gagawin ko? If I'm going to express this as percent volume per volume. Anyone? Yes, Miss Mary? Oh, hindi. Okay. Anyone? How can I express this in percent volume per volume? Okay? Yan ang pinakamadali, class. Di ba sabi natin, pag nag-express tayo ng concentrations, ayun, sige, Miss Mary.
Try lang, sir.
Yeah.
100 ml
Okay.
over 1,000 ml
Okay.
times 100.
Very good. Okay, correct, class. That's how you express this now. Okay, it's going to be percent volume per volume. So 100 divided by 1,000 times 100, okay, you get 10% volume per volume. So are we clear? Di ba, class, ang sabi natin, pag nag-express tayo ng concentration, pag percent concentration, that's just usually solute, kung ano man unit nun, over solution, anong total volume ng solution mo, times 100. Okay? So whatever percent concentration yung i-express mo. Alright? So halimbawa, kung yan ay percent volume per volume, so ibig sabihin, ml of solute over ml of solution times 100. Kung ito naman ay percent weight per volume, so that would be grams of solute over ml of solution times 100. Kung ito naman ay percent weight per weight, then that would be grams of solute over grams of solution times 100. Make sense? Does that make sense, class? Okay, so ganun siya. So halimbawa, kung ang binigay sa aking problem is naka volume per volume, gustong pagawa sa akin na weight per volume, pwede basta may specific gravity ako. Okay, provided I have specific gravity. Right? Okay. Buti hindi nagloloko ngayon yung natin. Ating sulat-sulat. So are we good? Okay. Okay. Pwede na bang mag-next slide? Ay, wait lang. Okay. Si Miss Eva nag-ano eh. Okay lang yan, no problem. Okay? Pero don't worry, class. Also, nag-record ba? Okay, nag-record. Okay, edit ko lang to. Alright. Now, let's try this one, class. Weight and volume calculation. So, grams of constituents equals tapos volume ng ating expressed as decimal. Okay? So, here's the problem, class. How many grams of potassium permanganate should be used in compounding the following prescription? Okay? So, halimbawa, ang order for potassium permanganate is dapat daw 0.02%. Okay? Then add purified water to make 250 ml. Okay? Now, ang question dito, class, is how much potassium permanganate should I be using? Ang sabi lang sa order is, ang kailangan kong solution should contain 0.02%. Okay? 0.02%. Right? Wait lang, Okay. Alright. So, again, class, ang problem natin here, let me just repeat, ang total solution ko dapat is 250 ml. Okay? 250 ml which contains dapat ang concentration ng 250 ml na to would be 0.02%. Alright? 0.02%. So, ang question is how many grams of potassium permanganate should I put in 250 ml of water, or a total solution, to make a total solution of 250 ml kung saan ang concentration niya is 0.02%. So, paano ko sasagutan to? Ang gagawin natin ito, class, mag-ratio and proportion tayo. Okay? Now, this is assuming, class, that this is weight per volume. Hindi na-indicate eh. Pero assuming natin ngayon, this is weight per volume. Okay? So, ang magiging ratio ko dito, class, would be 0.02 grams is to 100 ml. So, therefore, ilang grams ang gagamitin ko to make 250 ml? Right? Alam niyo na, class, yung ibig sabihin ito, di ba? Add. To make. QS add, mga ganun. Sufficient quantity to make. Familiar ba kayo sa mga terms na yun? Are you guys familiar with terms like QS add? Not so much? Yes? Pag sabing QS add, class, add sufficient quantity to make 250 ml solution. Alright? Kasi may makikita nyo ito sa mga formulas natin eh. Hindi pa ba kayo nag-acronyms? Common acronyms using pharmacy? Like, alam ba, PO? Per orem.
Wala pa po.
Wala pa po.
Saan pa ito tinis? Kasi tinitingnan ko nga sa syllabus. Normally, in my case, in my curriculum class, first topic namin lagi sa PharmCal is yung mga terms na ginagamit sa pharmacy. Okay, mga acronyms na ginagamit sa pharmacy. Kaya nga natitignan ko yung syllabus, sabi ko, ba't wala kaya dito? Ba't wala? So, I was assuming familiar na kayo. Okay, sige. Pag sinabi natin class QS add, halimbawa, potassium permanganate as QS add purified water, tapos 250 ml. Ibig sabihin nun, I just add enough water, kahit ilan pa yan, basta kailangan makabuo ako ng 250 ml solution. Basta solution yung bubuoy ko dyan. 250 ml solution. So, ibig sabihin, yung 250 ml solution na yan contains whatever grams ng potassium permanganate ko. Okay? Basta ang total product is 250 ml. That's the reason why, class, I can use this ratio and proportion. Kasi di ba ito ay 100 ml of solution. Ito, 250 ml solution. Alright? So, ang concentration doon na kailangan ko is 0.02%. So, that's 0.02 grams is to 100 ml. Then, X is to 250 ml. And then, X class would be 250 times 0.02 by 100. 0.5
0.5.
grams. Very good. Okay? So, 0.05 grams class ng potassium permanganate ang kailangan kong tunawin ang kailangan kong tunawin sa tubig to make a 250 ml solution containing a concentration of 0.02%. Make sense? Does that make sense? Okay.
Yes.
So, pwede naman natin class subukan. Sige sir, tingnan natin sir kung ilang percent yan. Okay, di ba sabi natin, solute divided by solution lang naman yan eh. Di ba? So, 0.05 grams divided by 250 ml times 100. Tingnan natin kung 0.02 to. Hindi ka naman, oo. Divided by 250.
Opo.
Alright?
0.02.
Okay. So, that would give me 0.02%. Okay, which is yung hinahanap natin. Okay, make sense? Very good. Alright. Next one, calculations given the weight of the solute and volume of the solution. Right? So, yun lang din naman to klase. Ang tanong dito is, what is the percentage strength, weight per volume, of a solution of urea if 80 ml contains 12 grams? So, sabi nga natin, class, pag percent concentration lang naman, it's just weight, solute over solution. So, again, depende na kung anong hinahanap dito. So, since this one is weight per volume, so obviously, ang solute ko dito would be weight of solute in grams over volume of solution, which should be in ml, right? So this would be 12 grams divided, times 100 to times 100. Okay, so it's 80 ml equals
15.
very good. Okay, 0 times 100 would be 15%. Huwag niyong kakalimutan, weight per volume. Alright? That's how you express class concentrations in terms of percentage. Para alam natin, ang ginamit ko pang measure ng solute is in grams, is in weight. Tapos ang total product ko is in solution. Ang total solution ko is in ml, is in volumes. Alright? So, ito dapat ang expression, ha? Wag kakalimutan. Kasi pag nagpa-quiz ako, I'm very particular kung anong klaseng percentage ang pinapakita niyo sa akin. Is it weight per volume, volume per volume? Okay? Mga ganyan.
Sir, pero hindi niya na po, iisa-isahin yung solution. Parang pwede mo nang i-straight to,
Oo naman, pwede naman straight. Okay? In this case lang, gusto ko lang pakita sa inyo, class, na ganito natin siya, ito yung proseso ng pag-compute. Okay, sa practice naman, class, Diyos ko, diretso calculator na lahat halos dyan. Hindi na nagsusulat. Pero syempre, para hindi tayo malito, sulat na lang. Okay, so next one, calculations given the percentage, weight per volume, strength, and weight of the solute. Okay, so halimbawa, ang tatanong naman ngayon class is in terms of ml. Okay, volume naman ang hanapin natin ngayon. So halimbawa, how many ml of a 3% solution can be made from 27 grams of ephedrine sulfate? Right, so halimbawa, gusto kong gumawa, ang sinasabi ng class ng problem na to is, gusto kong gumawa ng 3% solution. Isang 3% solution, which contains 27 grams of ephedrine. Okay, kumbaga, gagawa ko ng solution that contains 27 grams of ephedrine sulfate, ilan ang total volume niya dapat? Okay, ilan ang total volume niya dapat to make a 3% solution? Right, so how do I solve this? So, babalikan natin kanina class, di ba, ang percentage na to, again, assuming this one class, hindi nga sinulat dito sa problem to, pero assuming na automatic this is weight per volume. It is weight per volume. Alright, so therefore, it only means that 3 grams, okay, to make a 3% solution, you should have 3 grams dissolved in 100 ml of solution. Okay? So, kung gagamit ka ngayon ng 27 grams ng ephedrine mo, gaano karami dapat yung solution? So, yun yung X ko. Alright? So, therefore, X equals, hindi ko na mapakita in, out, out, ha? Hindi ko gets nyo naman na to. would mean I'm going to use, I'm going to make 900 ml of the solution. Okay? So meaning, if this is my product, ito kunwari, yung lalagyan niya. This product, ang total volume niyan should be 900 ml. And this product contains 27 grams of ephedrine sulfate. Alright? Pero ang total volume niya dapat should be 900 ml. Are we clear? Very good. Okay. At least nagigets nyo na ito, class, ha? Mamaya kasi medyo gagawin natin ito complicated. Just a little bit. Okay, we're gonna make this a little bit complicated. Okay? Pero at least now, nagets natin kung paano ito ginagawa. Okay. Now, what about volume and volume calculations? So here, class, ang question is, how many ml of liquefied phenol should be used in compounding the following prescription? Again, volume per volume. Alright, so this is 2.5% volume per volume. Alright? So, ang question ulit is, how many ml of liquefied phenol should be used in compounding the following prescription? Ang kailangan ko is a 2.5% solution. A 2.5% solution liquefied phenol. Alright? Tapos, ang total solution ko would be, and QS add, meaning add calamine lotion to make 240 ml total. So, therefore, ang gagawin ko lang dyan would be 2.5 ml of phenol in 100 ml of solution. So, therefore, how many phenol ang gagawin? How much in ml of phenol do I need to use to make 240 ml total solution? Again, this is total volume. Sorry. Okay, total volume ko yan. So, obviously, di ba sa 2.5%, ito yan. This is total volume. So again, this is also total volume. Okay? Ang order sa akin kasi is kailangan gumawa ng calamine lotion na 240 ml ang total volume, pero ang kanyang concentration should be 2.5% phenol. Right? So therefore, X would be equal to
6
Ayun, na-complete nyo na. Very good.
ml.
6 ml of phenol. Liquefied phenol. Are we clear? So, ibig sabihin, 6 ml of liquefied phenol ang ilalagay ko to make a total of 240 ml solution. Okay? Question, class. Since it is already in ml, okay, question ko na, gaano karaming calamine lotion dapat ko idagdag to make the 240 ml solution? How much calamine lotion should I add? How much of the diluent? Si calamine lotion yung diluent ko dito eh. Yeah, balikan nyo lang yung alikot natin yung alikot natin. Paano ba tayo nagko-compute ng diluent natin?
234.
Yes, Miss Elsen.
34.
Sorry, Miss Elsen?
234.
Very good. How did you get 234?
Sinabjak ko.
Very good. Di ba kasi ang total number of solution, total volume. Okay, kasi class, if you want to get the volume of diluent, okay, ang gagawin lang dyan, total volume minus volume of the solute. So, total volume natin was 240 ml. So, minus 6 ml of phenol. So, meaning, ang dadagdag ko to make the total, would be 234 ml calamine. Yan yung diluent ko. Kung dati ang ginagamit nating diluent si lactose, kasi solid tablet yun eh. Yung mga example sa alikot, right? Ginamit natin diluent, or di kaya ml din naman, water ang ginagamit na diluent. Pwede rin kasing diluent si calamine lotion. Familiar ba, kailan niyo ba si calamine? Yung color pink? Ginagamit yan, class, pag may kagat ka ng lamok, it's anti-pruritic, pangtanggal ng kate. Okay, sir, pwede bang paliguan yung mga taong makakate? Okay, paliguan ng calamine para mawala yung kate nila. Wala atang sagot sa ganung klaseng kate. Right, so nag-get sa class? Are we good? Okay, so ganun siya, class. Now, say for example, paano, class, kung naka-grams ito? Grams kunwari si liquefied phenol. Ang sabi dito is hindi siya volume per volume. Gram per volume pala to. So dito ngayon papasok ang importansya ni specific gravity para ma-convert mo siya to volume. So are we good? Are we clear? Okay. Next one. Ito na yung next topic natin. Calculations given specific gravity and volume of the solution. Yan, may specific gravity na involved. Right? So here, what is the percent strength, volume per volume, of a solution of 800 grams of liquid with a specific gravity of 0.8 in enough water to make 4,000 ml? Oh, excuse me.
I-register ko na ngayon.
Okay?
Agad-agad.
Okay.
mo malapit sa iyo, no?
Kaya ko yan. Okay. Okay. So, class, again, ang question lang naman dito is percent strength, percentage volume per volume. Yun ang hinihingi dito. So, equals unknown. Ito yung required. Ang given sa akin, solute is equivalent to 800 grams. Okay? Ang specific gravity niya would be 0.8. Tapos, ang total volume of solution, kasi sabi dito, enough water to make 4,000 ml. So, ibig sabihin, total volume of solution ko would be 4,000 ml. So, therefore, class, how do I solve for this? Okay? So, first things first, kailangan ko yung volume nito, 800 grams ko. Okay? Kailangan ko ito ma-convert to volumes. Volumes. Right? So, that would be mass over density or specific gravity. Tama ba? Potex. Dependent din ako sa ganito eh. Tama, mass over density. Okay? So, ang mass natin is 800 grams divided by 0.8.
1,000 ml.
1,000?
ml.
Okay. So, that would give us 1,000 ml for the volume. Okay? So, now class, percent volume per volume tayo ngayon. So, percent volume per volume. Pwede na eh, kasi ang solute natin is in ml na. Okay, this total volume natin would be 4,000 ml. So that would just simply be 1,000 ml divided by 4,000 ml times 100. And you get 250. Okay. Times 100. All right, 25%. This is again volume per volume. Huwag nyo kakalimutan yan. Okay? Nakita nyo na klase application ng ating specific gravity. So, depende kasi kung anong hinihingi sa inyong expression. Is it weight per volume per volume, or weight per weight? So, are we clear? Alright. Nice. Para pag nagpa-asynchronous activity na ako, kaya-kaya niyong sagutan. Okay? Dadamihan ko yung mga examples ng ganito. Right, next one. Calculation given the percent strength and the volume of an active ingredient. Okay? So, halimbawa, peppermint spirit contains 10% volume per volume of peppermint oil. What is the volume of the spirit that will contain 75 ml of peppermint oil? Okay? So, this time, class, anong hinahanap dito? Okay, gagawa raw tayo ng peppermint spirit na 10% volume per volume. Okay? Ngayon, ang gusto kong gamitin na total amount ng peppermint oil is 75 ml. So, gaano karami dapat yung solution ko? Nagets ba? Okay. Ulitin ko kasi ang sabi dito, peppermint spirit. Okay, peppermint spirit. Ito yung gagawin natin, peppermint spirit. Okay, normally daw it should contain 10% volume per volume peppermint oil. Now, ano ang magiging total volume ng peppermint spirit ko kung gagamit ako ng 75 ml peppermint oil? Right? In practice, class, usually ang kinocompute ko dito is how much peppermint oil do I need to put to make a certain amount of volume, total volume. Yun in practice, In practice, ganun yun. Pero in this case, for the sake of computation lang, para malaman nyo na pwede palang gawin ito, okay? So, binigay natin is, ang total volume ng peppermint oil na gagamitin, siguro inuubos na lang Inuubos na lang yung 75 ml nilang peppermint oil para makagawa ng peppermint spirit. Spirit class, ibig sabihin, it's a combination of oil and water na. Okay? It's a combination of oil and water. So a spirit, peppermint spirit, it's already a oil plus water na to. Okay? Na pwede ng pang-gargle, pwede ng inumin, pwede na kasi diluted na siya. Okay? Pero usually ginagamit siya for gargling. Para mabango-bango yung bibig. Right? So anyway, peppermint spirit ang gamit natin. So therefore, this is volume per volume. So hence class, ang peppermint spirit ko, 10 ml should be used to make a 100 ml solution. Now class, ang sabi dito is, gagamit ako ng 75 ml oil. Peppermint oil, 100 ml solution. So 75 ml nung oil, gaano karami ang solution na magagawa ko? Okay, yun yung dito, yun yung katanungan. Gaano karaming solution na magagawa ko? Therefore, yes, okay. X equals, wait lang 75 times 100.
70.
700, okay, very good. 750 ml solution. Yung spirit. Okay? Dito yung spirit. Are we good? Okay, that's a peppermint spirit. So if I want to make, ubusin ko halimbawa, yun na lang natin sa bote ko eh. So 75 ml, gawin natin spirit lahat. Okay? So kailangan 10% yung natin solution eh. Gaano karaming gaano karami ang total solution dapat? So sabi natin, should be 750 ml. Oh, ito, try na rin natin. Gaano karaming diluent ang ilalagay ko? Gaano karaming diluent? Gaano karaming tubig? Try nga natin. How many water? How much water should I add? Okay, to 75 ml oil. To make a total solution of 750 ml. Yes, Miss Eva.
Sir, is it 675?
Yes, 675. So, paano natin nakuha yun? Yeah, Miss Eva, tuloy mo na.
750, which is the total solution, minus 75 ml of peppermint oil. So, equivalent.
Yun na yan.
Yun na.
Kumbaga, yun na yan. Kumbaga, yun na yung tubig. Okay? So, are we clear, class? Okay, so kumbaga maghahalo ako ng 75 ml oil plus 675 ml ng tubig to make the total solution, 750 ml solution. At pag pinaghalo ko yung dalawang yun, kaya lalabas, it's going to be 10% volume per volume of peppermint oil. Right? Okay. So next one, calculations given the percent strength and specific gravity of the ingredient. Ay, 430 na pala! Tapusin ko lang to Okay? Tapusin ko lang to, tapos yung matitira natin, I'll make this into a video na lang. Dagdag natin. Okay? So, calculations given the percent strength and specific gravity of the ingredient. So, halimbawa ito, if a vet liniment contains 30% volume per volume of dimethyl sulfoxide, how many ml of the liniment can be prepared from 1 pound of dimethyl sulfoxide? Okay? So, kumbaga class, katulad to kanina nung peppermint oil natin, nag-uubos na lang tayo ng active ingredient natin. Okay? Ubusin na lang natin. So, ang tanong lang dito is how many ml of the liniment, okay, total volume niya, magagawa natin kung 1 pound of the solute ang gagamitin natin, which is dimethyl sulfoxide. Okay? Now, class, again, ang preparation natin is expressed in volume per volume. Alright? It's 30% volume per volume. So, ibig sabihin, to make this happen, okay, I need 30 grams of dimethyl sulfoxide. So, hindi ko alam kung ano yung chemical formula niya Okay? To be diluted to make a 100, sorry, not grams, ano ba yan? ml to I need 30 ml of dimethyl sulfoxide, okay, to create 100 ml solution. Okay? Ngayon, class, dahil naka 1 pound ito, I need to convert it first, right? I need to convert this first into ml kasi ang expression natin is volume per volume. So sabi natin, class, if you want to get volume, That's DMV. Okay, mass over density. Sabi, hindi ko maalala talaga. Mass over specific or density or specific gravity. So therefore, dito tayo sa side, volume would be equal to 1 pound. Convert ko muna to 1 pound. This is 2.2 in kilograms. Okay? Well, actually, I need to convert this first to grams. So 1 pound, sabi nga natin, 1 pound equivalent to 1 kilogram is 2.2 pounds. Tapos 1 kilogram is 1,000 grams. Kasi kailangan ko siya in grams. Okay? So 1 divided by 2.2. Alright? Times 1,000. And I get 454.55 grams. Right. So in grams na yan. 454.55 grams. So therefore, volume, 454.55 grams divided by, ano yun natin, 1.1. Equals,
413.
ayun, thank you, 413.22 ml. So yun ang volume ko. So therefore, class, 30 ml of dimethyl sulfoxide, okay, to make a 100 ml solution. So kung gagamit ako ng 413.22 ml of dimethyl sulfoxide, gaano karaming preparation ang magagawa ko? Gaano karaming solution ang magagawa ko? Therefore, X equals, okay, times 100 divided by 30. We get a 1,377.41 ml solution. Are we good? Are we clear? Okay. So, ganun karaming solution na mabubuo ko kung gagamit ako ng 413.22 ml nung ating dimethyl sulfoxide. Yes, Miss Mary.
Yung 1.1 po na density galing dun sa SPGR,
Yes.
1.110.
Yes. Kasi diba sabi natin kanina, whatever your specific gravity is, yan na rin yung density. Tanggalan mo lang ng units. So for today, before we start with Module 3, allow me muna class to pick up from where we last left off, which is about the calculation using ratio strength. Okay? So alam niyo naman class, diba, that we oftentimes we can actually use ratio strength as another means of expressing concentration. Okay? Ang pinaka-popular, of course, will always be the percentage, okay, such as this one. Okay, where in percent yung binibigay nito. So alam naman natin, class, if you're given an expression like this, say for example, this is weight per volume expression, that would mean that it contains 0.02 grams of solute, okay, dissolved in 100 ml of solvent. Okay, so basically, class, ganyan siya. Now, if you look at this, class, this is actually the way, ito na yung ratio strength natin. Okay, technically, that's that. So we can write it down, class, as 0.02 is to 100. Pwede na yon. However, class, kapag nagpapakita kasi tayo ng ratio strength, okay, kadalasan, class, dapat yung sabihin natin numerator should always be 1. Okay? This 1, yung 0.02 dapat 1 lagi yan. Kumbaga, yung basta yung numerator, yung para sa solute natin, the value should always be 1. Now, how do I convert this, class, to a value of 1? Ang 0.02 na to. Okay, so if I want to convert this to 1, class, obviously, I have to divide both the numerator and the denominator by 0.02. Okay? So ang lalabas niyan, class, so divide ko to pareho sa 0.02. Ang lalabas niyan would be 1 is 2. So 100 divided by 0.02, 5,000. So are we clear? So therefore, class, 0.02%, if you express it in ratio strength, it's equivalent to, in ratio strength, that is 1 is to 5,000. Okay? Kung gusto natin, class, subukan ibalik ito sa pagka-percent niya, okay, kung 1 is to 5,000, ano gagawin ko lang? That's just 1 divided by 5,000 times 100. And that would give you Okay? 0.02%. So does that make sense, class? Okay?
Yes po, sir.
Alright.
Yes po.
Very good. So basta basically, class, kailangan nyo lang tandaan lagi, kapag mag-express tayo ng ratio strength, percent to ratio strength, okay? Ang gagawin mo lang naman dyan is, i-break apart mo lang to, kumbaga yung percentage. So yun na nga, 0.02 is to 100. Pero nga, sabi ko, kapag magpapakita ka ng ratio strength, ang numerator mo dapat 1. Okay? Technically, yung parang numerator mo, ano ba to? Means? Extreme pala to sa extreme. Extreme portion to. Okay? Pero anyway, basta yung numerator mo, class, should always be expressed as 1. And to do that, divide the numerator by itself. Okay? Then the denominator, which is the 100 here, so yung denominator natin, okay, technically, ito ang numerator. Right, so the denominator, class, ang gagawin lang natin is divide it by the numerator. Okay? And therefore, class, you'll get an expression of 1 is to 5,000 in this case. Right? At tapos, class, kung gusto mo namang baliktarin ang ratio strength, gagawin kong percent strength, then, class, the numerator will just simply be divided by the denominator times 100, which is here. Okay, then you get percent. Okay, percentage for your concentration. Now about this one, express 1 is to 4,000 as percentage strength. So sabi nga natin, class, ang gagawin lang dito is 1 divided by 4,000 times 100. That would simply be 0.025%. Make sense? Okay, di ba? Apakadali lang. It's very easy. Now, calculating ratio strength given the weight of a solute in a specified volume of solution. Okay? Let's say, for example, a certain injectable contains 2 milligrams of a drug per ml of a solution. What is the ratio strength? So, class, dito pa lang, binigyan ka na kayo ng parang proportionality. Okay? A certain injectable contains excuse me, 2 milligrams, okay, per ml. Now, remember, class, when expressing a percentage or a ratio strength, sabihin natin ratio strength, okay, dapat, class, kung ito ay weight per volume, such as in the case here, okay, the weight should always be expressed in grams. Volume would be expressed in ml. So, obviously, class, yung 2 milligrams na to, kailangan ko pa itong i-convert into grams. Okay? So, to do that, I'm sure sanay na kayo mag-convert. Okay, just divide this by 1,000 and you'll get 0.002 grams. So, therefore, class, ang proportionality ko would be, so instead of 2 milligrams is to 1 ml, it should be 0.002 grams is to 1 ml. Okay? So, kung gagawin ko siyang, tanggalin natin muna yung units. So, that's 0.002 is to 1. Now, ang sabi natin, class, hindi pwedeng numerator mo is dapat, sorry, ang numerator dapat 1 lagi siya. So, again, divide both sides by the numerator. 0.002. At ang kalalabasan niya ay 1 is to 1 divided by 0.002, 500. Okay? So, this is my ratio strength. So, are we clear? If I convert this to percentage, ano naman siya? Okay? So, obviously, 1 divided by 500 times 100. Okay. In percentage, so that's 1 divided by 500 times 100, you get 0.2%. Alright? So, are we clear? Any questions so far, class? Okay naman.
Wala po. Okay naman po.
Okay, good. Okay? Basta kung may questions kayo, nahihiya kayong magsalita sa microphones ninyo, you can always type your questions, class. Okay, naka-open naman lagi yung message box ko dito. Okay. What about this one? What is the ratio strength, weight per volume of a solution made by dissolving 5 tablets, each containing 225 grams of sodium chloride and enough water to make 1,800 ml. So medyo combination na to ng mga pinagkakagawa natin so far. Okay. So class, anong gagawin muna natin? So sabi natin, kailangan weight per volume ang ratio strength. Right? So tapos, ano ang solute na ginamit natin? So 5 tablets, of sodium chloride, and each tablet contains 225 grams. So 5 tablets, tapos each containing 225 grams of sodium chloride, then it was dissolved in 1,800 ml of water. So sulat na natin given natin. So weight of solute equals 5 tablets. Tama? 5 tablets ang nilagay natin. Tapos sabi natin, each tab, 1 tab, contains 2.25 grams of sodium chloride. Okay, tapos ang weight, sorry, not weight, volume of solution is equal to 1,800 ml. Okay? So sabi dito, ang required natin would be ratio strength equals unknown. So magiging solution natin, class, would obviously be, first get the weight of the solute. So that's 5 tabs times 2.25 grams per tab. Okay? So para makancel out ang tablet natin, ang lalabas would be 2.25 times 5. 11.25 grams. This is the total weight of solute. And then ang total volume natin would be 1,800. So therefore, class, ang mangyayari niyan would be, ang expression natin would simply be 11.25 grams is to 1,800 ml. Sabihin natin, yes, ay, nawala.
Sir,
Yes,
Sir,
Miss, ano? Yes, Miss
paulit
Julia.
po yung paano nakuha yung 11.25 grams.
Okay. Yung 11.25 class, okay, tandaan natin ha, ilang tablets ang ginamit natin, ang gagamitin daw na i-dissolve natin sa solution. Sabi kanina, okay, the solution will be made, okay, by dissolving 5 tablets. 5 tablets. At ang sabi natin, each tablet contains 2.25 grams of sodium chloride. Okay? Now, dahil each tablet is 2.25 grams, how many grams ang 5 tablets? Okay? So obviously, I'll just have to multiply 2.25 sa 5. Kasi nga 5 tablets ang gagamitin natin. Okay, tapos nag-cut out each tablet. So kumbaga, 1 tablet is 2.25 grams. Okay? Eh, ang gagawin daw natin, 5 tablets niyan. 3, 4, 5. So lahat to, 2.25 grams. So therefore, times 5 lang to. So you get 11.25 grams. Tapos lahat ng tablet na yan, i-dissolve natin in a water, in a solution na dapat ang total volume 1,800 ml. Total volume. So dahil sinabi kong total volume, ang solution, it means it contains both the volume of the sodium chloride tablets together with the volume of the solvent to be used, which is obviously water. Are we good so far?
Yes po, sir.
All right. Okay, so anyway, 11.25 is to 1,800 ml. So technically, yun yung proportionality natin. So sabi nga natin, hindi naman pwedeng, hanggat maaari, hindi pwedeng, hindi 1 yung numerator natin. So again, divide both sides of the equation by the numerator, which is 11.25. So this would be 1 is to 1,800. Sorry?
160
Ayun.
po.
Okay, very good. Thank you so much. So ang ating ratio strength will be 1 is to 160. Okay? Now, ano naman yung, kung kakaling ipapresent natin as percentage, weight per volume, eh, pwede naman tayo dito mag-umpisa eh. 1125 11.25 divided by 1,800 times 100, we get 0.625%. Okay? Pwede rin naman itong gamitin natin. 1 divided by 160 times 100, that would give you pretty much the same thing, 0.625%. All right, make sense?
Yes po.
All right, good, good. Okay, what about this one? So calculations based on ratio strength. So how many grams of potassium permanganate should be used in preparing 500 ml of a 1:2500 solution. Actually, pag ganito class ang expression, napakadali na. Okay? Kasi naka-ratio na agad siya. So, parang sasabihin mo lang dyan is 1:2500. Okay? 1 dito meaning the solute. 2,500 will be the volume of the solution. Okay? Then, that would just simply be X is to 500 ml. Sabi nga natin, in, out, out. Or means, extremes. So that would just simply give you 500 divided by 2,500. That's 0.2 grams. So are we good? Okay. Kasi tandaan nyo class ha, usually pag ratio strength ito, di na nga na-indicate kung weight per volume to. Dapat sinabi dito eh. It should be weight per volume. Right? Okay. So that's ano yan. Problema na yun nung gumawa ng problem na to. Kinopya ko lang naman to eh. Okay, pero ganoon siya dapat class. Right? You need to present din naman kung weight per volume yan, volume per volume. Pero class, normally, pag hindi sinabi, ano ba, bigyan ka ng percent strength or ratio strength. Okay, tapos hindi sinabi kung weight per volume per volume, parang matik yung class, weight per volume yun. Okay, kumbaga parang ang standard expressions kasi natin lagi would be to use weight per volume as a means of expressing our concentrations. Right? Any questions? Okay.
Wala po.
Alright, good. So mukhang wala pa naman so far. Next one class, parts per million and parts per billion. Okay? Kaya inumpisa mo natin siya with ratio strength kasi class, it's in relation to this one. Kumbaga gagamitin natin ang ratio strength to express our concentrations in terms of ppm or ppb. Okay? Normally class, ginagamit natin yung parts per million or parts per billion if the solute is very dilute. Or kumbaga the strength of the solution is very dilute. Okay? Like halimbawa class, the amount of chlorine in the swimming pool. Okay, sa tingin mo, pwede ba yung 1%? 1% chlorine in the swimming pool? Okay, technically class, bawal yun. Okay, that would be too potent. Okay, usually the allowable class is parang 0.0006% of chlorine. Okay, so it depends. Pero basically class, kung sobrang haba na ng zero natin before our number, our whole number, di ba sabi natin kasi as much as possible, we don't express values na sobrang daming zeros. It's either we convert it into scientific notation or convert it into a unit na mas mabilis maintindihan. Okay? Or nasa tenths, nasa hundreds, or nasa thousands. Okay? So, therefore, class, kung sobrang dilute ng iyong solution, then it's better to express it as parts per million or parts per billion. Ibig sabihin, 1 part of your solute that is dissolved in a million part of the solution. Nagets ba? Okay, that's 1:1 million. So obviously kung 1 is to 1 billion, parts per billion, so ibig sabihin 1 part is to 1 billion. Okay? So are we clear so far? Right? Ulitin ko lang class, ginagamit lang ito to express strengths of solutions that are very dilute. Normally class, ginagamit nito for, say for example, for contaminations. Okay? Up to how much contaminants ba ang meron dapat sa tubig natin. Madalas kasi marinig mo to sa mga balita natin, di ba? Ano ba, yung fecal coliform concentration, ilan ng parts per billion na allowable, yung sa Manila Bay. They usually express that in parts per billion or parts per million. So, depende na yun kung ano yung solute na tinitingnan natin. Pero basically, class, ginagamit itong expression na to for very dilute solutions. Another example, class, would be the amount of fluorine you are drinking in a tap water. Okay, so hindi naman pwedeng mataas yung fluoride content nun. Okay, if I'm not mistaken, class, dati nangyari ito sa Cavite. Okay, wherein ang mga tao, masyadong mataas yung tubig sa Cavite noon, sobrang taas ng fluorine content. Kaya ang nangyari, class, nagmotling yung mga ngipin ng mga bata. Yung parang chalky yung itsura ng kanilang teeth. Normally, class, pag mukhang chalky yung mukha ng teeth nila, that indicates, class, na-expose ang tao na yon, okay, yung ngipin nila na-expose sa too much fluorine. And normally, you can get that through your drinking water or yung toothpaste na ginagamit sa inyo pang toothbrush. Just so you know, class, iba ang fluoride requirements ng baby sa adults. Kaya huwag nyo ipang toothbrush ang Colgate na pang adult sa isang baby. Lalo pag developing pa lang ngipin nila. They have a separate toothpaste which contains smaller amounts of fluorine, okay, as compared to what we find in our regular toothpaste. Alright, so FYI na lang sa inyo yun. Kung may baby sa bahay nyo, huwag gagamit ng Colgate, ng toothpaste na pang-adult. Okay, pwedeng maging chalky or maging brittle yung ngipin ng baby natin pag lumaki siya. Okay, another use naman class of parts per million and parts per billion would be for maximum contaminant levels. Ito yung sinasabi ko sa inyo, yung mga contaminations. So this usually quantifies the highest level of contaminant that is allowed in drinking water, below which there is no known or expected risk for a person's health. Okay, above which pwede na magkaroon ng risk, usually in terms of, halimbawa, kung ang contaminant natin would be mercury, say for example, in drinking water. Okay, alam naman natin class that mercury is poisonous, okay, yung ating element na yon. So therefore class, very minimal amount lang dapat meron yan sa ating drinking water. Okay? Kaya nga nauso na yung mga purified water, right? Okay, back nung maliit pa ako class, hindi uso yon. Ang iniinom namin na tubig usually tap water lang. Okay, pero nga dahil nga may mga contaminations, blah blah blah. Although tap water now class in our lumalabas sa mga nawasan natin is deemed to be safe. Deemed to be safe. Okay? Pero sabi natin, most people would say, better safe than sorry. So, bumibili tayo ng mga purified water. Kaya yung purified water na yon usually either through distillation or through reverse osmosis na filter or na-purify. Tinatanggal yung mga contaminants. Any existing contaminants. Pero just so you know, class, we still need minute amounts of minerals in our water. Okay? Because those minerals, class, are essential for our diet pa rin. Kaya nga kasi hindi advisable na uminom talaga ng purely distilled water. Okay, when I say purely distilled, yung talagang zero content yung minerals niya. Okay, hindi naman sa hindi pwede, pero it's bad for the health. Okay, drinking pure distilled water. Right? Although sa market naman natin, wala naman talagang pure na distilled water. Okay, we don't usually have that. Usually, ang pure distilled water ginagamit sa laboratories as a solvent. Right? So let's talk about some calculations regarding parts per million and parts per billion. So ito lang naman siya eh. Express 5 parts per million of iron in water in percentage strength and ratio strength. Now normally class, if you do this as ratio strength, ganito tsura niyan. Okay, 5 parts per million daw to, di ba? So sabihin that's 5 is to 1 per million. So if I'm going to express this as ratio strength, divide both sides by 5. Okay? Parang lalabas is 1 is to, wait lang 3, 4, 5, 6 divided by 5. That would be 200,000. 1 is to 200,000. Now that is of course ratio strength. Okay? As percentage naman, what pwede natin gawin is 5 divided by 1 million. 3, 1, 2, 3, 1, 2, 3. Okay, times 100. That would give me, okay, so this one is 5 divided by 1 million times 100 to get the percentage. Ang kalalabasan would be, 0.0005% or 5 times 10 to the negative 4%. Either way, tama rin naman yun. Okay, or pwede nyo rin naman gawin, kunin natin yung percent ratio, yung percentage strength using the ratio. That's just 1 divided by 200,000 times 100. Pretty much you get the same thing rin naman. 5 times 10 to the negative 4%. So are we clear? Okay, basta class, pag parts per million, whatever yung numerator na to, is to 1 million yan. So obviously, kung parts per billion, edi 1 billion na yun. Okay? Are we good? Make sense?
Yes
Yes
po.
po.
Okay, good. Okay, so what about this one? The drinking water in a community has detected lead in its drinking water at a level of 2.5 parts per billion. Now, the EPA's MCL, okay, just imagine class papakita mo yung ratio strength mo 0.0005%, di ba? Ang hassle. Kaya usually ang ginagawa lang is 5 ppm. Okay, mas madali pang tingnan. Usually parang feeling ko pang aesthetics na lang to. Okay, pero it's there, so aralin na lang natin. Okay, so 2.5 parts per billion. The EPA's maximum concentration level is set at 15 parts per billion. Right? So obviously, hindi pa naman ganun kadelikado ang 2.5 parts per billion concentration of lead in the current drinking water na meron. Excuse me, sa scenario natin na to. So express the difference between these two values as ratio strength. Okay, so ano ba yung difference between the two? So that's 15. Express mo natin sa isa-isa. Mas maganda yun eh. Okay, so 2.5 parts per billion would just simply be equal to 2.5 is to 1 billion. 1, 2, 3. 2, 3. 1, 2, 3. Okay, so express this in ratio strength. That would be 1, 2, 3, 1, 2, 3, 1, 2, 3. Ang hirap nito. Oh my gosh, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's 8. So that's 1 is to 4, 1, 2, 3, 4, 5, 6, 7, 8. 3. 400 million. 1 is to 400 million yun. Ang current lead levels. So, ang dito, EPA's MCL is 15 parts per billion. So, sabi natin that's gonna be 15 is to 1 billion. 2, 3, 4, 5, 6, 8, 9. 1 is to 3, 4, 5, 6 divided by 15. It's 1, 1, 2, but 6 lang to. 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 15. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8.67. 3, 66 million, 666. Yun na yun. Alright, so that's the ratio strength here. Okay? Okay, huwag natin i-express as percentage. Napakaliit na nito. Okay? So if you want to check the difference class between the two, so obviously that's just 15 minus 2.5. ppb minus 2.5 ppb. Tingnan natin kung gaano kalayo pa naman. So 15 minus 2.5, that would give me 12.5. 12.5 parts per billion pa naman yung difference. Pero sabi ko nga, convert natin daw siya into ratio strength. Express it as ratio strength. So that's 12.5. Kaya usually class, I don't ask questions like this anymore. Basta gusto ko lang malaman ng estudyante na may ganito at naintindihan nila kung paano kinukuha. Okay na ako. 8, 9. Right? This is 1, is 2. 2, 3, 4, 5, 6, 7, 8, 9. Divided by 12.5. Ilang 0 to 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1. That's 80 million. 1 is to 80 million. Okay, ito yung difference. Okay, difference between the two values.